Okay, all this is our video of how to construct Lewis structures of some covalent compounds. And before we start, just make sure we have our 5 rules for drawing these structures, which we're going to refer to. We have these 5, and we also have these other 2 ideas. One with respect to hydrogen, that it always goes on the outside of the molecule, and that its outer level is full with only 2 electrons. The other important thing to note is that fluorine is the most electronegative element on the periodic table. So with that, we'll follow the rules and we'll start with H2O, or water. So the first thing we're going to do for water is we're going to find the total number of valence electrons available. For hydrogen, there is 1 valence electron for each hydrogen atom. We have 2 hydrogens in this molecule for a total of 2 valence electrons. For oxygen, if we were to draw out the electron configuration or glance at our periodic table, we know that it has 6 valence electrons, bringing our total to 8. Next rule in our list for Lewis structures is to put the least electronegative atom in the center, which should be hydrogen, but hydrogen is always on the outside, so by default we are going to put oxygen in the middle. Okay, we're going to put hydrogen on each side, and we are going to construct single bonds with a pair of electrons between each oxygen and each hydrogen. Our next rule is to complete octets on the outside atoms. Hydrogen's octet is complete with 2, so it's in good shape. We've used 4 of our 8 possible electrons. We're going to add the other 4 around the oxygen to complete its octet. So if we look at the structure, each hydrogen has 2 electrons completing its octet, and the oxygen in the middle has 8 electrons completing its octet. A cleaner way to draw this picture would be oxygen in the middle. Instead of the 2 dots, draw a single bond line to the hydrogen, draw another single bond line to the hydrogen, and then leave the unshared pairs around the oxygen. We are still using all 8 electrons. Remember that any bond line is equal to a shared pair of electrons. So we've used 2, 4, 6, 8 electrons, and we've completed the octets on all of the atoms. Next one we're going to look at is HCN. First thing again, we're going to find the valence electrons available. Hydrogen has 1 available. Carbon has 4 available valence electrons, and nitrogen has 5, bringing our total valence electrons available to 10. Place our least electronegative atom in the center, but never hydrogen. Carbon is slightly less electronegative than nitrogen, so carbon goes in the middle. I'm going to put hydrogen on one side and nitrogen on the other. I'm going to use 2 of my 10 electrons to bond the carbon and the nitrogen. Use 2 more to bond the hydrogen and the carbon. Continuing, I have 6 electrons left. Now, one might think to go 2, 4, 6. And that solves the octet rule for the nitrogen. The hydrogen's octet rule with only 2 is solved, but we have an issue with carbon only having 4 electrons displayed in the diagram. So rule 5 in our list says that if central atoms do not have an octet, we're going to move electrons from outer atoms to form double or even triple bonds. So we're going to take these two electrons and migrate them here, and these two here. And here's our quick redraw. So we're going to go carbon, hydrogen, nitrogen, and we're going to place not one, not two, but 3 pairs of electrons between the carbon and the nitrogen. Final unshared pair out there. We've still used our 10 total electrons, 2, 4, 6, 8, 10, but now we've satisfied octets for every element. Hydrogen, carbon with its 8, and nitrogen with its 8. We're going to redraw it one more time. We're going to show a single bond between the hydrogen and the carbon. We're going to show a triple bond between the carbon and the nitrogen, and we're going to show one unshared or lone pair of electrons. The final one we're going to do in this video is NH4 positive. A reminder that when things ionize or have charge, they have gained or lost electrons. So, again, with our idea of total electrons available, N has 5, hydrogen has 1, and there are 4 hydrogens present. So we would think we'd have a total of 9 valence electrons available, but the entire ion has a positive 1 charge, meaning that it has lost an electron somewhere. So instead of 9 possible electrons, we only have 8. So again, placing our least electronegative element in the center, nitrogen. And we're going to place a hydrogen on each side. And we are going to bond all 4 of the hydrogens to the nitrogen. Notice we've used all 8 of our valence electrons, 2, 4, 6, 8. Hydrogen is again satisfied with its 2, completing its octet. And a better way to write this is probably with our single bonds. N single bonded to H 4 times. And then we're going to say this entire thing in brackets carries a +1 overall charge. So it's a different notation style when you're building your Lewis structures. You would do a similar game with something like SO4 2-, but instead of subtracting an electron because we had a positive overall charge, we would add 2 electrons to make that overall charge -2. Feel free to watch as many times as you need. Make sure you're following your 5 rules and placing the least electronegative element in the center.